Hello guys, hope you all are doing well. So, in the continuation of the previous gate series, we have completed section A of 1995 and some questions of 1995 of section B. And today we'll complete section B of 1995. I have left few intentionally. I have left few questions because they are of nowadays outdated questions. They are of few of process equipment design and some of the derivations. So they are in today's scenario, gate is not asking those questions. Okay, so all the important question we have completed, so no need to worry about those questions. Just focus on the questions what we have completed. Okay, so we'll start with question. Estimate the heat transfer area for an exchanger to cool an organic liquid from 105 degrees Celsius to 50 degrees Celsius. The hot liquid will flow at a rate of 10,000 kg per hour. So we have to convert it into in kg per second, and will be cooled by using circulating foul water containing some salt. Okay, the cooling water will leave at 40 degrees Celsius. It is proposed to use one shell pass and two tube passes exchange for availability. Okay, so there is a FT. You might confused with FT. So FT is a correction factor. It always comes whenever more than one tube is there. One shell pass, okay, and two tube pass. That 2 and 4, 4 shell and tube heat exchanger. You might have heard sometimes 2 4. So 2 is the shell passes. That means the fluid will pass 2 times from the shell and 4 times from the tube. Okay, so this is the meaning. So whenever there is a more than two tubes, a correction factor will come. Okay, so the correction factor is 0.5, 0.85. Okay, so 2 4 means 2 for 2 times it will pass through the shell and 4 times it will pass through the tube. Okay, so at first we will see the diagram. So we know that heat exchange is a counter current flow. So if there is co-current, then it will the question will mention it that it is co-current. Okay, so this is the diagram, and nothing much to explain in this diagram. So energy balance over heat exchanger, we know that heat lost by the hot fluid is gained by the cold fluid is equal to 8 theta m. So with the correction factor, the formula just result like this. Just Ft will be multiplied in this. Okay, so putting all the values, we will find theta m. Okay, so putting all the values and we will get the answer. So this is straightforward question. Okay, 20.33 meters. Okay, switching over to the next question. A small model reactor is to be built for scale up studies of the behavior of the proposed large industrial stir tank reactor having 1000 time capacity. The bigger unit of 2-meter diameter will have a liquid depth of 2 meter. This will be fitted with a 4 bladed. This is bladed. Okay, bladed, 4 bladed blade custom turbine of 0.6 meter dia. Both are geometrically similar. Okay, estimate the dimension of the smaller unit for optimum stir speed 330 rpm observed in the smaller model. What will the required speed in the industrial unit? Okay, so we want to erect a plant of erect a reactor, a stir tank reactor of big units. So for the study, we are just making a model and studying their dimension and the flow pattern and all things. So the question is asking, we have the dimension of bigger one. What is the dimension of the smaller one? The condition is both are geometrically similar. Okay, when the geometrically similarity is there, the dimension ratio of the dimension will be equal. Okay, so let us see the bigger one. So this is the turbine. D2 is 0.6 meter. It is given in the question. L2 and D2 is equal to 2 meter. Okay, now V2 is equal to 1000 V1, right? This is 2, this is 1. So V2 is equal to 1000 V1 given in the question. Okay, since the both are geometrically similar in the small model as well, D and L will be equal, because in the bigger model D and L is equal. Okay, so putting the value pi d square by 4 into L2, 1000 into pi d1 square by 4 into L1. So this all we have, this will cancel out. Okay, so d square into L2, 1000 into d1 cube, because d and L are equal, so L1 equal to d1 equal to 0.2. Okay, now both are geometrically similar, that when d1 by dt is equal to this. Okay, the ratio will be d1 by d2. So d1 we just have found 0.2 and d2 we given in the question, it is 1. Geometrically similar means the dimensions of the bigger unit and the smaller unit, whatever they have, the ratio will be equal. So d1 by dt is also equal to 0.1. Okay, so the d1 will be 0.06 meter. So we have found the dimension of the smaller unit. Now case 2, what will be the RPM of the bigger model when we have the RPM of the smaller model? Power per unit volume kept constant. So what is power in agitation and turbine and agitation? Power number is equal to P rho n cube d5. This power number is a constant. We can write it as K as well. Okay, so no need to confuse. So this is a constant. Okay, just denoted by NP. So P will be equal to NP rho n cube d ki power 5, where this d is the diameter of the turbine, not the diameter of the tank. Remember that this is the diameter of turbine, not the diameter of the tank. Okay, in 2003 or 2004 there is a question. In the question itself it is given that this d is the diameter of tank. No, that is wrong. This is the d that is the diameter of the turbine. Only then the question will solve. Okay, so P will be this. Volume, general volume formula is this. Okay, so L is equal to D in both the cases. So this is the thing. Just divide P by B. So N rho n cube d5 pi by 4 d cube. Okay, write this for once for model and one for the industrial scale. So I have written, and what will pi will cancel out? Pi by 4 will cancel out. Pi by 4. NP and rho will cancel out. NP and rho will cancel out. What else is left? N cube d to the power 5 of the model, d cube n cube of the industrial 0.6 upon this. So RPM will be okay. Now second case, Reynolds number does not change. So Reynolds number we know that rho n d square by mu. Just put all the values. Rho will cancel out, mu will cancel out. So n d square for model and liquid, we will get n for industrial is equal to 3.3 RPM. Okay, this is for you. Okay, so straightforward question. The same question GATE 2016 asked. That was my first attempt, and I was so stupid that I haven't done the previous year. Okay, so if you have any confusion you can ask. Okay, that is straightforward question. Might have some confusion related to the dimension, and so just if you have read the dimensional analysis as well, so there is a geometric similarity and kinematic similarity, those all velocity will equal, those kind of thing, you will get an idea. Okay, switching over to the next question. Air flows through a packed bed of powdery material of 1 centimeter depth at a superficial gas velocity 1 centimeter per second. A manometer is connected to the unit register a pressure drop of 1 centimeter of water. Okay, 1 centimeter of water. The bed has a porosity of 0.4. Assuming Kozeny-Carbon equation valid, the study estimate the particle size. So particle size we need to find the density of air, viscosity of air. Okay, so we have Argan equation. Since the Kozeny-Carbon equation is applicable, this will become 0. So this is the Kozeny-Carbon equation. Minus del P by L. Minus del P we have 1000 because 1 centimeter of water 1000. 10 is the gravity. 1 centimeter of the water 0.01 divided by length is 0.01. That is the depth. Length is equal to depth. Okay, so 0.01. So putting the values, 10 ki power 4 is equal to all the values you will put. Ultimately dp will be 0.123 mm. Straightforward question. Okay. It is necessary to dry a batch of 160 kg of wet solid material from 30% to 5 moisture content under constant and falling rate period. Okay, so very first thing, 30% and 5%. Constant rate period, falling rate period. Calculate the total drying time. Consider available drying surface area 1 meter square. So available surface area है 1 meter square per 40 kg dry solid. Okay. At a constant flux of 3 into 10 power minus 4 kg dry solid per meter square second. Critical moisture content we have and equilibrium moisture content we have. C. Critical moisture content, what is the unit? Kg moisture upon kg solid. Okay. It is not kg moisture upon kg mixture. Mixture means solid plus moisture. That means this is the mole ratio or mass ratio. Similarly, equilibrium moisture content is the kg moisture upon kg solid. But here 30%. That means it is the percentage with respect to the mixture. So we have to find out this is small x. So we have to find the large x1 is equal to 0.3 divided by 0.1 minus 0.3. So this is kg moisture divided by kg dry solid. Why there is dry come? Because when you remove the moisture, then only dry things will remain. Okay, this is the 0.3 is the amount of the moisture, and when you subtract the moisture amount from the mixture, then only dry, whatever there is a dry solid, it remains. Okay, so there is kg dry solid. That's just so 0.3 divided by 0.7. Okay, and similarly x2, that the final 0.05, 1 minus 0.05 is equal to 0.0526 kg moisture per kg dry solid. Why I am subtracting from 1? Because 0.3 and denominator is 1. That's all. Straightforward. Okay. Okay. So total drying time TT is equal to LS upon A and C. This is LS is the dry weight of the stock, but we have given 160 kg of the wet stock. So we will calculate dry stock. Okay, there is a trick. I will no need to calculate this LS. Okay, this will work. So I'll tell you. First I will write the formula x1 minus xc. Xc is this. Okay, plus xc minus x equilibrium ln xc minus x equilibrium x2 minus x equilibrium. Okay, so now LS is the dry weight. You have two method. First, calculate the moisture content 160 kg wet solid into 0.3 is the initial moisture kg moisture divided by kg. Either it is wet solid because moisture is there, or mixture, moisture plus solid. So I will write mixture or wet solid. Wet solid. So wet solid and wet solid will cancel out. So it will give 160 into 0.3, 48 kg moisture. So in the 160 kg of wet solid, 48 kg is the moisture, remaining 112 is kg dry stock. So I put okay, so 112 kg is dry stock. So for 40 kg dry stock there is 1 meter square. So into 112 kg dry stock, how much will be required? 2 point something will be there. Okay, 2.4 or 2.8 something will be there. Okay, but instead of doing this kind of thing, put directly this, the value of A upon LS, because ultimately it will give the same value. If I will put 1 meter square, that is area, upon 40 kg dry solid into NC is 3 into 10 की power minus 4 kg dry solid per meter square second x1 point 3 divided by 0.7, 0.3 divided by 0.7, 0.43, 0.43 minus 0.2 plus ln 0.2 minus equilibrium 0.05 divided by 0.0526 minus 0.05. Okay, solve it, you will get the total time. Either you can this or you can this, the similar. So LS is 112 kg dry stock divided by how much area you will get for this, 2.8. Ultimately when you will cut, you will get 40. Okay, so directly put this value. Okay, so total time you will get in second, and in hour it will come around 34 hours. Okay, straightforward question. If you have any confusion, just comment. Okay, the equilibrium data for the distribution of solute C between feed solvent A and extracting solvent B is given. Okay, it in a counter current or contact operation, 100 kg per second of feed containing 20% C in A weight by weight is treated with pure solvent. Okay, so suppose this is C plus A, here 20% is C. Okay, that means small, what is X, what is Y? X is here C, X kgc kga, kgc kga, yani C and A, kgc. So x1 is equal to 0.2 and capital X1 will be 0.2, 1 minus 0.2. Okay, and treated with a pure solvent. So this is the pure solvent we are treating, suppose B. So this is Y2 is equal to 0. To reduce the concentration to 5%. So reduce the concentration 5%, x2 is equal to 0.05 and x2 is equal to 5, 1 minus 0.05, 0.0526. Calculate the solvent rate for the operation with 2.5 times the minimum solvent rate. Okay, so this whole quantity is 10 kg per second. In this whole quantity, C is equal to 2 kg per second and A is equal to 8 kg per second. Okay, so applying balance, this is Y1, apply balance. So we will use mole ratio, that is the capital values, mole ratio, because moles of solute divided the moles of the solvent. So A is what? Only the solvent, because 8 kg is the solvent, feed solvent. 8 kg solvent per second into x1 0.25, because this value is 0.25. What will be kg solute upon kg solvent. Okay, minus 0.0526, the unit will be same, kg solute plus kg solvent is equal to B y1 minus y2 is 0. Okay, so kg solvent and kg solvent will cancel out. Okay, kg solute will remain. So this is solute balance. So 8 into 0.25, now I'll write direct 0.0526 is equal to B minimum value. For minimum value, we know that equilibrium relation will come. So y is equal to mx. But here is the thing, we need to see what is y, what is x. In absorption we use y is equal to mx, but in absorption y is what? The solute. But here y is solvent. So we need y1 is equal to m. We need to find m. So m is equal to, since it is passing through 0 0, so this is y is equal to mx plus c. So c is 0 because it is passing through 0 0 origin. So m will be y2 minus y1, that is 0.28 minus 0 divided by 0.45 is equal to 0.62. So 0.62 into x1, x1 is 0.25, so 0.155, 0.155. So put this value here, 0.155. So you will get b is equal to 10.2 kg per second. That is the minimum value. For minimum, y1 comes from the equilibrium relation, but we have b actual 2.5 times the b minimum. So it will give around 25.5 kg per second. Okay. So this is straightforward question. Now, a counter current plate absorber is to be installed for scrubbing an air mixture containing 5% ammonia by volume. So suppose we have this. Okay. 5% ammonia NH3. The scrubber is fed with a water containing, okay, so water is not pure, so X2 is equal to 0.002 mole NH3 per mole water, that is mole ratio. The scrubbing water flows at a rate of 1 mole per water per mole of air. So see this, what is the, see the unit, mole of water per mole of air. So it is the value of L by G. They have given the direct value of L by G, 1.0 mole water mole air. Okay. It is necessary to absorb 85%. So 85% of this value x, sorry, this is y, small y1. If I will calculate capital Y1, then 0.0526, and 0.85 of this value y2 will be 0.85 1 minus 0.0526, right? So this is 0.00789. Okay, because this is the concentration of ammonia in the feed, and 85% of this value will go into the solvent, then what remaining, 1 minus of this value is go in the outside, okay, with the air. So K value is mole of NH3 per mole of air, this is Y. So Y upon X we have, so Y is equal to 0.8x. Okay, Y equal to mx. Calculate the concentration of NH3. It is saying concentration of NH3, that means it is asking small x2, the mole fraction. Mole fraction means concentration, not mole ratio. If you will write mole ratio in place of mole fraction, the answer will be wrong. And estimate the number of stages necessary for this operation. Okay. So very first thing, G is equal to y1 minus y2 is equal to L x1 minus x2. Okay, so we y1 is 0.0526 minus 0.0500789. This is equal to 1. X1 is x1 is oh sorry, we have to find x1, 0.002 we have given x2, so x1 will be 0.0446. This is the value of x1. To find the mole, this is mole ratio. To find the mole fraction, see, x1 is equal to small x1, 1 minus x1. So If you find small x1, then it will be x1 1 plus x1. So 0.0446 1 plus 0.0446 will be the value of small x1. Okay, around whatever will be the value. Okay. Now, number of stages necessary for this operation. So KBS equation we will use. Okay, we will use KBS equation. So we will use KBS equation. So number of plate will be y1 minus mx2, y2 minus mx2, 1 minus 1 upon a plus 1 upon a ln a. Okay, this whole value ln will come ln. Okay, so we will put the value ln y1 is 0.0526 minus mx2 0.8 into 0.002 y2 0.00789 minus 0.8 into 0.002 1 minus 1 upon a. We need to check a. If a is equal to 1, then formula changes. A is L upon mg. So L by g is 1.8. So it is around 1.25, I think. 1 divided by 0.8, 1.25. So 1.25. So same formula will apply. So 1.25 will be, and 1 upon 1.25 will be 0.8, 0.8 plus 0.8 upon ln 1. Here 1.8 will not come, 1.25 will. Okay. So always be careful when you are putting the values. So it will have 1 minus 0.8, that is 0.2 into 0.0526 minus 0.8 into 0.002, okay, divided with 0.00789 minus 0.8 into 0.002 plus 0.8 ln divided by 1.25 ln 3.96. So number of plate is 3.964. Can't be fraction, so approx 4. Okay, so this is the question. This question I'll not solve, I'll just leave it up to you. We have solved these kinds of questions many times in the previous questions. Okay, previous years. So liquid A decomposes in a batch reactor by second order kinetics. If 50% of it is converted in 5 minutes, how long it will take to reach the 75% convergence? Okay, so we have second order kinetics, that is, what is Ra? dCA by dt is equal to K. What is Ca? Ca naught 1 minus Xa. Okay, whole square. What is Ca? Ca naught 1 minus Xa, right? K Ca naught square 1 minus Xa square. So Ca naught is become, if you will differentiate it, then minus 1, differentiation of 1 will be 0, minus 1 will become plus, this become dxa by dt is equal to K Ca naught 1 minus Xa square dxa 1 minus Xa whole square is equal to K Ca naught dt. Okay, at t equal to 0, conversion will be 0. At t is equal to t, conversion will be Xa. Okay, when you will solve this, okay, integration, you will get this. Putting the value at time is equal to t1, that is 5 minutes. Conversion is what? 50%. So 4.5 will remain -1. And the time we required for 75% conversion, that means 0.25 inverse. So it will give t is equal to 10 minutes. Okay. This question is important. When a thermometer at 30 degrees is placed in a water bath at 90 degrees Celsius. Okay, so the thermometer initially was at 30 degrees Celsius. So this is the steady state. Xs is equal to y is equal to 30 degrees Celsius, where x is the x is the bath reading, the atmosphere in which the thermometer is placed, and y is the thermometer reading 90 degree, that is x at t equal to some time. Initial rate of rise in thermometer temperature is 2 degree per second. What is the time constant of the thermometer, assuming it is first order device with unity steady state gain? Okay. What will be the thermometer reading after 1 minute? Okay. So initial rate of rise 2 degree Celsius per second. Okay. For first order system, we have this equation. Yt is y minus ys, xt is x minus xs. This remains same. Differentiate equation 1. This is okay. Initial rate of rise at t equal to 0. At this is at t equal to 0. Xt will remain same because it is a constant value 60. One differentiation will be 0. E to the power 0. If you will differentiate this equation, this whole equation you will differentiate, you will get this, because ys is the steady state value, that is constant. Okay, this whole value is constant, so you will get yt, this is the value at some time, 0 minus e equivalent t by tau into 1 minus 1 by tau. Okay, put the values, so you will get xt by tau is equal to 2 degree per second. This is the initial rate of rise, and this is the initial rate of rise of the temperature. Put xt, tau will be 30 seconds. Okay. Thermometer reading after 1 minute. So put all the values, you will get the answer. Okay. 72. Amplitude ratio corresponding to crossover frequency 10 radian per second for a process time sound to be 0.1. So this is the amplitude ratio. What is the ultimate gain? This is the straightforward formula. 1 upon 0.1, that is 10. Gain has no unit. Period of oscillation, this will be in cycle per second. 2 pi upon omega crossover, we have a crossover frequency of 10. So 2 into 3.14 divided by 10, whatever is the value. Proportional gain, direct formula, 0.5 into Ku. Ku is ultimate gain, that is 5. Okay, so we have completed 1995, and within couple of days I'll come upload 1996, and if you have any kind of confusion, anything, just comment it below. I'll reply as soon as possible. Bye guys, take care.